Hello everybody, I am Ben from Team Panic, and today we're going to be doing a bit of a bot breakdown for very obvious my 13 kilo over the head angled spinner that you have seen. There was a lot of comments and things on its fight videos about how I built certain things and what parts I used and what motors were on here and all that kind of stuff. So I figured the best way to show you guys all of this is to do a full breakdown video and show you everything that goes into the building of this ginormous overhead spinner. So we're going to do this in 3 different parts because there are essentially 3 different subsystems at work here. There is the weapon system, the drive system, and then the actual chassis itself. So we're going to do those in some form of order. I will put time codes in the description, so if you want to just jump straight to whichever bit that you want to see, you can go ahead and do that. For now, right now, this thing is actually in kind of display mode. The weapon is only held on with a regular nut, not a nylock nut, and there is nothing inside. So if we actually open her up by throwing that this way and pulling out the one remaining bolt in the base plate, you'll see that there is nothing inside, and that there's actually an awful lot of room in here. Once we get this bolt out, come on, out you come. So first and foremost, we do have Panic painted on the underside here, because when I first built this robot, I did not do any design calculations for whether or not it'd be able to drive upside down. So I just assumed that it couldn't and spray painted Panic on the underside, thinking that if I ever saw that in a fight, I was going to be panicking and I was probably going to lose it. And then here we go. This is what the robot looks like inside at the moment. So it's still got its drive motors in place. It does not have its brushless motor for the weapon in place yet, or any of the electronics that sit in around the outsides here. So it's time for me to start pulling this stuff down, and we'll get going. I think we'll actually look at the chassis first, followed by the drive system, or maybe the drive system first. Actually, that's going to be better. We'll do the drive system first, then the chassis, and then the weapon system at the end. And yeah, like I said, let's get started. Okay, so here we go. This here is the entirety of the drive system, and it is worth noting that by the time I was fighting in Australian Nationals, this whole system was completely independent of the weapon. So it had its own battery, its own wiring harness, and everything else. It also had its own receiver, which is actually not on the table right now, but it's the tiny little receiver that I was talking about a couple of weeks ago in the little recommendation video that I did. Now, so this is everything, as I said, for the drive. So the main component here is actually 2 drill motors out of very cheap Kmart drills. And yeah, these things run pretty well. I've used these in a bunch of different 13 kilo robots. Actually, pretty much all of my 13 kilo robots, other than Strange Young Man version 2. Strange Young Man version 2 did not have these in, but pretty much everything else I've run has. The one minor upgrade here is I've always 3D printed the motor mounts for these, but I found them to be a little bit brittle when I was fighting in the 13 kilo weight class. So these motor mounts are actually just ever so slightly squishy. They're printed out of TPU. So if we have a look at this guy, I can just give that a tiny little bit of squish. It's got quite a lot of infill in it and a lot of perimeters, which means that it's not very squishy because it needs to actually hold the motor relatively rigidly in place, but it is just a little bit squishy, which gives it just enough flex to not transfer hits into the motor. The motor can actually move around a little bit during hits and bounces, which is a very good thing. So these guys were mounted in place with these over here, which are M5 80mm long bolts, which did a pretty good job holding everything together. 1 or 2 of them are just ever so slightly bent, I think from some of the big hits, but they held everything together pretty well. Now, there's also these panels down the bottom. So these are little buff spaces that hold the motors away from the actual chassis, just so that they get down low enough to touch the ground where I went for the wheels to touch the ground where I wanted the wheels to touch the ground. There is also this slab of 6mm mild steel that rests in underneath the motors. This is basically just ballast. The robot was coming in underweight, so I added some ballast in underneath the motors so that the motors always had weight underneath them. Basically, it just means that the whole robot touches the ground a little bit better, or at least the back wheels touch the ground a little bit better and get more traction, which is always nice. So speaking of the wheels are a 3-part concoction, actually 4-part concoction. So they are a TPU wheel, which means once again they get a little bit of give in them. You can see that here when I just give that a bit of a squeeze. And then they have a bike tire glued and screwed around the outside. If you ever put bike tire on a wheel, glue and screw. Super glue and tiny little wood screws are your friends in this case. If you just screw, you're likely to rip the actual rubber up off the screws, and then you're left with a wheel with screws that are your contact point to the ground. And you can see here, this wheel got cut and it still holds together really well. There's nothing that you can do to get this rubber off even. It's done very, very well. Now, on top of that, this has some hex hubs that I made myself. These hex hubs aren't actually what they appear. They are only skin deep. They're about 6mm thick. And if I have a tool around here that I can get these off with, I will, but I do not think so. Actually, there we go. We can do it with an M5 bolt. So we'll push these out and give these a bit of a show. So you can see they don't go all the way through, but they do have bolts that go from one side to the other. These are just tiny little M5 bolts, and these helped the hubs get a better grip on the wheel and also made sure that the hubs could not ever round out inside this, because it is TPU, so it's always going to have a bit of flex in it, and I didn't want that flex to give away and have the hubs round out in here. So these hubs are not the greatest idea. They should have been made in aluminium. They started off as this. This is HDPE, and HDPE holds a thread decently. In fact, this one, which is the front one, has threads in all 4 of the outer holes for M5, and that held its threads really well. The problem is the other side. So this other side is the actual contact point for the motor. They're supposed to thread onto the motor shaft, and that's how you get your power output. That and some reverse thread bolts that go in the other end of the motor, so as to keep your motor together and give you that nice power out. However, I only made a handful of these and only tapped a handful of these in HDPE, and I destroyed them. They don't really hold a thread too well when that thread is trying to go forwards and backwards and forwards and backwards and drive a whole robot. So I had some wooden prototypes that I'd made and threaded with me at the event, and that's all I could do was to put these in place and hope for the best. Unfortunately, these rounded out as well, and yeah, going into day 2 of Australian Nationals, I had to change this whole idea because these hubs were not good enough. On the whole though, these wheels are great. All I need to do is make better hubs for these, and these things are going to be ridiculously good. As I said, they took a bit of a shot on one of these. This was just from a saw blade. It cut the rubber a little bit, but didn't really do anything else, mostly because as it got hit, it bent down and bent away, which was really good. That actually held up very, very well. And I have 4 of these, so literally, like I said, I'm just going to make better hubs, and then these things will actually be really good, and we'll run these again in the future. So that's the wheels and most of the hardware side. The electrical side is pretty easy. There are 2 of these bot bits, 30 amp version 2 speed controllers that I've run with drill motors in the past. These things are bulletproof and reliable. Love them to pieces. We have a tiny little wiring harness back here. So in here we have the battery connector where the power switch goes, or the power link goes. And then in under here we have 2 bolts and some ring terminals that connect everything together. So connect the power side with the ESC side. Then the ESC side is just XT60 connectors to hold that together. And then yeah, finally we have a Turnigy 1.8 amp hour battery. This is just a 4S battery, and in actual fact, this battery is the reason why the electronics are separated. These motors that I have, the drill motors, they survive 4S okay, especially in 3-minute matches, but if you run them on 6S, which is what I was running the weapon at, they burn out, and they burn out quick. So I didn't want to be constantly replacing these motors all the time, so it was much easier for me to separate the electronics out and run 4S on these and 6S on the weapon, and have two completely separate electronic systems. Like I said, this set even had its own receiver, and it all worked well in the end. I connected both receivers to the same transmitter, and it just worked. They didn't have to do too much fiddling around with any of that. Okay, let's move on to the next bit. Okay, so this is the chassis mostly disassembled. I've left these little angle brackets in here. So these little angle brackets are just 3mm alley angle brackets that have 5mm bolts, and then also have a 6mm riv nut in them. These are just to hold the base plate on. That's why I'm using riv nuts. Riv nuts anywhere else are probably going to fail and die, but on the bottom, especially of this robot, that if I see the bottom, everything's going badly anyway, I figured it was going to be okay. So while I designed this chassis to be as simple as possible, it's also kind of like it is in some regards, but it's also not in some regards. So if you have a look over here, you can see the sheer amount of hardware literally just to mount armor and bits onto here. This is not any of the drive stuff or any of the weapon stuff. This is literally just armor for the actual robot itself. And there's 3 whole different types of hardware that are needed, and then there's different types again inside each of those. So it's not the greatest, and I probably could have simplified this a little bit, but for now it did work, so that's a good sign. So we'll start with the actual chassis itself. So the chassis itself is 6mm Hardox 450 for the front wedge and the main plate, the plate that actually holds the weapon and then the brushless motor. And then it is 3mm Hardox for the sides, the motors, the motor plate back here that holds the drive motors, and then the very back panel as well that has all of these weight holes cut out of it. Now, this is so light and everything because I knew that I was going to be mounting armor onto it, and that armor came in this form. So these are 2 plates of 10mm thick HDPE, and the whole idea behind those was that they were going to absorb any hit that I took from the back. And in actual fact, if you have a look here, this here is where Forge, the drum spinner, hit me, and it's literally just kind of like chewed a little bit of my paint off and kind of made some little plastic flappies, and that's all it did. This same drum spinner, when it gets a good bite on people, can absolutely throw them over. This plastic saved my robot a lot of pain there because it's literally just chipped away and not given the drum spinner anything good to get hold of. So these 2 panels were mounted to the chassis with M8 bolts, and also some tiny little rubber wobblies down here. Now, these things here were literally sold as rubber grommets for electrical cabling, and they came like this. I then cut them in half so that I had 2 little rubber wobblies and sat them behind every single armor panel so that the armor panels themselves were spring-loaded against the chassis, essentially. So when they get hit, they're not transferring all that energy into the chassis. Some of that energy is being taken up by the little rubber wobblies, and they're kind of bowing in or bending or whatever needs to happen. So that was my armor plan for this whole robot, is plastic armor with a little bit of give to it, so every hit that I take that's not directly on metal isn't actually going to transfer all the shock load into the robot. So on top of this and the shock loaded wheels that we were talking about earlier, I put a lot of shock loading into this robot just so that any real big hits weren't going to be an issue for me. And it seems like this plan had worked really well. All of the hits that I took didn't really seem to shake the robot that much. So I'm going to keep going with these rubber wobblies system. I think it's working pretty well. Speaking of rubber wobblies, the side armor, which are these panels here and sit on the actual sides of the robot, those were also mounted with rubber wobblies. These are 6mm thick HDPE, and they were mounted with M6 bolts. So slightly smaller bolts because I wasn't expecting these to get hit as much, so I didn't want to use the weight on M8 bolts. If I was going to do my design again, I would probably just mount these with M8 bolts and yeah, simplify my whole bolt system that I had going on. That would have just made life a little bit easier. So there's two of these, one for each side. They are obviously mirror pairs of each other, and they have a nice little cutout in the back of them, a little round cutout for the wheels to go through. Now, I will say, before we move on from these HDPE panels, these things are a little bit of the bane of my existence right now. I got white HDPE because that's all of the plastic supplier that I went to had, and I tried to then paint them back black and green to fit with the color scheme that I wanted for the robot, but I did not do any real research before doing this and just kind of assumed that a plastic undercoat would work on HDPE. It did not. So these things scrape the paint off of them really, really easily, and it's really annoying because everywhere they go, they leave tiny little paint flecks behind. So the suitcase that I took this to America and to Australian Nationals with is just full of paint flakes. The robot itself is full of paint flakes. Every surface I put it down on is full of paint flakes. So word to the wise, if you are going to paint HDPE, do some proper research behind it, sand the surface or blast it with heat before actually applying paint, because that is going to help you quite a lot. And yeah, do some testing before you paint your HDPE and just assume that everything is going to work, because otherwise you will end up with the paint equivalent of glitter all over your robot, which was not fun. Okay, so then moving on, the final two panels that I have down here, these are Lexan panels, 3mm Lexan panels that sit in the big gaps up the top here, either side of the weapon mount. Now these were done for two straight reasons. One is to knock a lot of weight out of the robot. These 3 or 4 holes up here knock something like 1.5 kilos to 2 kilos out of the robot, which was just insane. And also so that I could use this panel to hold my weapon links in place. Now we've all seen how this went over in the States. It didn't work very well because of course the weapons, the power links got sucked up out of the robot and into the weapon and destroyed themselves, which was a bad move, and I do need to replace these at some point and do something a little bit different, but I think the actual panels will stay as they are. 3mm Lexan panels in underneath this gigantic rotating weapon are more than enough. The weapon, as long as the weapon is spinning, these panels are never going to get touched. This one has a nice big saw nick in it from that first fight in Australian Nationals where this weapon didn't spin and I was fighting the drop saw. Once again, this guy's also got a nice big nick in it, but he got all the way through just barely on one of the cuts, and then cut the corner off over here. But I think that's more about, he got most of the way through it and it just kind of snapped with the vibrations, whereas when he was cutting the actual main thing, he didn't get very far through at all. So these panels also provided protection for the electronics and batteries. So the electronics and batteries were mounted on either side and actually just duct taped in place. Every single fight, I was just pulling the batteries out, charging them, putting them back in, and duct taping them to the sidewall and just leaving it at that. That was good enough for the most part to keep the batteries out of the way and protected from anything else. I think the next version we're going to do something a little bit different so that there's actually a box that the batteries sit in, but for now that worked pretty well. There's also a tiny little piece of Velcro down the bottom here, which is where I have Velcroed in the receiver for the weapon system in the Australian fights. There's also one on this sidewall where the receiver for the whole system went during the American fights. But yeah, so there you go. That's the chassis. It was a pretty simple build. Once everything was to here and cut in metal, it was literally just bolting it up into the shape I wanted it, and welding it all together, because the laser cutters did a pretty good job at getting everything exactly as it was supposed to be. All right, so time to move on to the weapon. And this is everything for the weapon system, including the 2 different blades. So I had 2 blades cut, one as a spare, just in case anything happened to the first blade, and something did happen to the first blade. So while I was fighting in America, I bent the tips quite badly on this first blade. And I did a little video PSA about not having thin tips on weapon blades, mostly because of this blade here. So this was my American blade, and this was my Australian blade. The Australian blade I cut down with an angle grinder, just cut printed a little template and then cut across the end of the template to get some flat tips. That didn't work very well, but it worked well enough. I then mounted everything onto its actual mount and balanced it by balancing it up on 2 blocks and just spinning it to see where it would fall and all that kind of stuff, and just kept hitting it with the angle grinder until it balanced relatively well. So both of these blades are the same material. They are both 10mm thick Hardox 450, and they are 2.5 kilos and 2.3 kilos respectively. So with the wingtips, it is just a little bit heavier because, of course, there's more material there. So those blades, I actually did pretty well. The blades themselves held up, other than the really thin tips, which we're not going to put on a new design in the future anyway. So let's take a look at how all of this stuff was mounted. So they were mounted onto these. These are 2 aluminium 6061 hubs that were handmade, so lathed down by me. They have a pocket in them to hold the bearings, top and bottom, and then the bottom has 6 tapped holes. So these are M10 high tensile bolts. There's supposed to be 6 of them, but when it's in display mode like it is right now, I only run a couple of bolts in it because there's no point having all of the bolts in. So these are tapped, 6 taps holes, and then we have a spot for the belt to go around, but we'll talk about that more when we get to talking about the brushless motor. And then, yeah, the top part is literally just a hunk of 6061 aluminum. That has started, aluminium, not aluminum. Anyway, that has actually started to get some threads eaten into it by repeated impacts. I'm not sure if you can see those down in that hole there, but yeah, those were hand lathed by myself at Sane Makerspace just before going over to America. So moving on kind of further down, we have these guys. These are 20mm tapered roller bearings is what they're called. So they sit together like this, and this one is getting a little bit crunchy because it's been used a lot, and there's a lot of paint and arena gunk starting to get into all of the bearings in here. And these sit in the pockets made in the aluminium. So they are relatively tight. They can kind of wiggle loose a little bit, so I don't actually have to like use tools to get them out or anything, but they do sit pretty tight in there. And they were designed so that the bearing is actually the highest point. You can see when I do that this bearing is the highest point. So when everything was bolted together, the lock nut on the end of the bolt touches the top of the bearing, and then the actual under bearing is the only thing touching the actual chassis of the robot, which meant that everything was rolling pretty nicely. And these bearings are phenomenal. They take shock loads in pretty much all directions, and they spin really freely, unless of course you've gunked them up with paint and arena gunk and stuff. These ones I will clean before using them again, but I also do have a couple of spares lying around somewhere. Let's get that back out of there again, just like that. Cool, so that leads us on to our bolt. So this here is the weapon shaft that I use. It is an M20 hardened bolt. It's a 10.9 high tensile steel bolt and a nylock nut that goes on the other end of it just here. This thing I was kind of expecting to break, to be perfectly honest, but it held up really, really well. There are some unaired fights as of yet, but this bolt held up beyond my expectations. This is one bolt did every single fight, and it's not even slightly bent or slightly warped in any way, shape, or form. It has held up really, really well, and there's been some big hits that this robot has dished out and received. So yeah, on the whole, that system worked really, really well. This bolt is relatively heavy, but it's definitely worth the weight for the fact that I did not have to worry about my weapon system at all. Then we move on to the brushless motor. So this brushless motor here is a generic longboard motor from Banggood. I think it's a 50-55 or a 50-45, or maybe it's no, it's not a 50-50, it's a 50-55 if it's anything. So for those of you who don't know, the numbers on a brushless motor are the can diameter and then the actual length from the mounting plate down to the back of the motor here. So like I said, I think this is just a generic 50-55, and it is a 400 kV brushless motor. Now, I could have gone higher than that, but 400 kV, or 400 or 600, one of those two. I could have gone higher, I could have gone to 800, but this was spinning these blades somewhere in the order of 3,000 RPM at full speed, and that was more than enough for me. That I really did not need much more of. Then we have the actual pulley that sits on here. So this here is a HDT 5mm belt pulley, and I hand cut or hand drilled and hand tapped a tiny little bolt into here, or yeah, a bolt hole into here, so that I could have a locking bolt in there. So this sits on there, and then this bolt gets tightened down. All of this was mounted, there are 4 M4 holes in here, and those holes were just drilled into the body, and M4 bolts were put on top. That's also why I had to lay down the back of this steel pulley, so that it would fit in those holes and wouldn't interfere with the bolts that were going on underneath all of that, because they had to sit just in under here, which did make that a little bit tight. On the whole, it didn't do too badly. There is a few kind of scrapes up the top here where that bolt, the grub screw in there, came a little loose and it wandered up and down on the shaft and it got hit by the blade. There's actually some marks on the back side of both of these blades where it's hit that pulley. You can see here there's some nice big marks over this side. This is approximately where the pulley is. So there you go, that kind of shows you where it was hitting. And that was literally just because the grub screw wasn't nylocked in properly in a couple of the fights, and it, yeah, floated around a little bit on the shaft. It didn't actually stop turning the motor, it just floated up and down on the shaft. So that was interesting, to say the least. But this motor has plenty of grunt. I don't think that I pushed it to its absolute limit. It didn't really get all that hot. It got a little bit warm, but I wouldn't say hot. I think it's perfectly fine to keep using this thing, and maybe even run it at a higher voltage to get a bit more speed out of it and get more speed out of the blade. So speaking of the electronic side of things, while I was fighting in the States, I was running this, which does not look very recognizable right now. This is an 80 amp red brick ESC. That was what was running it in the States back when I was running the entire robot on 4S, and this thing worked like a charm in the States. It was absolutely fine, and it was working pretty well in Australia up until I had some junk caught in the brushless motor, and then I fried this ESC. Next up, we put this 100 amp brushless ESC in here. Thank you to Michael for basically donating this to me because I fried it in its first and only fight. This was not great. It blew up the capacitors on the back of it and sprayed capacitor gunk through the inside of my robot, which was not fun. It did get it spinning though, and it got the weapon spinning enough to do enough damage to win a fight. So on the whole, I wasn't too unhappy with that. And also, like I said, it was given to me, which is very, very nice and it allowed me to keep going in the fights. And then the final ESC that we put in was a Vesk, or in actual fact, one of these, which is a Turnigy brand Vesk. These are the Hobby King version of a Vesk, and these things work pretty well. I can't really comment on how it went in the robot because those fights have not been released yet, but I am going to say that I will continue to use a Vesk going forwards because I have a feeling that I'm going to have a lot less issues with those going forwards, especially if I start trying to kick the voltage up higher with my weapon bars. Speaking of voltage, over here we have the battery pack that powered the weapon in Australia. So this is a 2.65 amp hour 6-cell LiPo battery, so it gets up to about 24 volts, which was really good and spun the weapon really, really fast, which was good fun to see. Of course, that was when the weapon was working and it wasn't being stopped by the fact that there was junk inside the weapon motor. Of course, this electronic system also had its own wiring harness. This was literally just battery to ESC through the connector, through the power link here. So this is an XT90 power link. Anything over 4S and anything that's going to draw considerable current, I always use XT90s for. I don't use XT60s as a power link unless it's, under 4S. And pretty much I'll only ever trust like 2 drills like I did with the drive for this robot on an XT60. Everything else has to go through at least one XT90 like this guy. It's something I'm going to change going into the next system, I think, because of that fight that you guys saw with me destroying these power links, I kind of want to avoid doing that in the future. And then, just the receiver that got Velcroed into place in the robot. So there you go. That is the weapon system. And because it looks kind of cool, here is a shot of, 90% of what is, what was in the robot. I could not fit everything on this table. As you can see, I'm running out of space already. All of the electrical system is out and there's a few bolts and stuff still sitting down in the box that I contain everything in. But yeah, that is most of the robot right there. And yeah, it did pretty well on the whole. I'm going to put this thing back together eventually. The chassis is going to remain the same. I think we're going to change the weapon out. We might get some new weapons cut for it before we use it again. But everything else worked pretty well on the whole. I might maybe change up the gear motors, the drill motors, because they are a little bit fragile and they also are forcing me to run 2 separate electrical systems in the robot, which I can do, but I don't need to do it, so we'll try and avoid that for the next time. Anyway, there you go. I hope you guys have enjoyed this one. I hope this gives you a bit of a better idea of what is in this robot and what went into it and all of the parts and bits and pieces that actually go into building a pretty decent 13 kilo robot. If you have any questions about any of this stuff, please let me know in the comments down below and I will try my best to answer every question that you have about the overall build for this 13 kilo combat robot. Hope you guys enjoyed that one and I will see you in the next video.